Lesson number 6, definite integral. So what's a definite integral? So it's actually an integration problem of f of x d of x with some boundaries a to b. Alright, so for example, I have this one, the integral of x dx from 1 to 6, for example. So how am I going to find the integral of this? So first you need to integrate x. So just integrate x, so that will be x squared over 2. And then what you're gonna do is you write the boundary from 1 to 6. Then after you write the boundary, you need to plug in the 6 here. Okay, you plug it in there, so 6 is squared divided by 2. Then you subtract when you plug in the 1 here in this integrated function. So 1 is squared over 2. So, which is equal to 36 divided by 2 is 18 minus 1 over 2, which is equal to 17.5. So this is the answer to this question. Now, what's the geometrical meaning of that one? What's the geometrical meaning of that? So this x here, that's actually your y is equal to your function x. When you draw that one, you know that if x equals 1, y is 1. If x equals 2, y is 2. So let's say that's my 1. That's my 1 there. That's my 2. That's my 2, maybe that. And then I connect, right? So this one is my y is equal to x. Now, what is the meaning of this from 1 to 6? So meaning from here, from 1, and let's say for example that this is my 6. Okay, let's say that's my 6. So if you notice, I have here this trapezium. Alright, and when you look at the area of that trapezium, when you look at the area of that shaded region, let's try to find the area of that shaded region. So what's our formula for trapezium? We know that this part here, but what is this one? Well, we know if x is 1, y is 1 because y equals x. If that is 6, this one is also 6. So that's also 6 there. So meaning the area of the trapezium is now this one, which is 1 plus, so I'm looking for the area. So 1 plus this one here is 6. Alright, times this height here, 6 minus 1, which is 5. Then you divide it by 2. Now, what is this one? So 1 plus 6 is 7 times 5 is 35 divided by 2, 17.5. Look at that. That is 17.5. That is also 17.5. So therefore, what does it mean is that the definite integral of the function is actually the area under the curve. Okay, so let me just write it down. The definite integral f of x dx from a to b is the area, so that is the area under the curve. Alright, so meaning if we have this function, so and let's say this is your graph, that is the graph of your f of x, and let's say you want to have from a to b. Alright, from a to b, the area of that region R is this one, so that is that area of the region R. How would you describe that region R? So the region R is actually bounded So what we can say, bounded, bounded by this line, which is x equals a, and we have this line, which is x equals b, okay, and this one is the x-axis, okay, bounded by x equals a, x equals b, x-axis, sorry, I should insert here, bounded by the curve, okay, bounded by the curve, the x equals a, and x equals b, and x-axis. What does it mean? So this is the curve, alright? So the region is bounded by that, the x equals a, the x equals b, and this x-axis. So that is how you're going to describe this region. And take a look, the integral gives you the area under that curve, okay, or the region that is bounded by all of this. So let's try to have an example in the next part of the video.